Okay, so they want us to use these theorems that we know and find the zeros of this polynomial function. Okay, now I would always check to see if it factors first, and it turns out that this one does. Your book doesn't do it that way. I'll show you that at the end of the video. So we're just going to assume it doesn't factor, because a lot of times they don't factor. So what do you do? Well, this is what you do. You start with the rational zero theorem. So you take P. So the factors of 3 are 1 and 3. And then you take Q. So the factors of Q are 1 and 3. Or the factors of 3 are 1 and 3. So you're going to have 1 over 1. You're going to have 1 over 3. And you're going to have 3 over 1. And you're going to have 3 over 3, which is 1, right? Okay, so I think I did them all. Plus or minus. Squeeze that in. Now, so there are 6 possible rational zeros, okay? Let's try one. Let's try 1. I always try 1 first, right? Okay. Now, this is a note here. This is 3rd degree, so we're looking for 3 zeros, okay? All right, so here comes the synthetic division. 9 and 3 is 12. This doesn't look like it's going to work. Nope. I don't even always do the whole thing as soon as I know it doesn't work. So not 1. Let's try -1 and see if that works. All right. -3, 6, -6. 1 and -6 is -5. That doesn't look good. 5, and I get 8. So no, that doesn't work. What did I miss? I feel like that should have worked. 3 is 6, -6, -5, 5, 8. Nope. All right, let's try. I'll avoid the fraction. I'll try 3. I don't think 3 is going to work. It's going to get too big. They're all positive. So let's try -3. All right, 3, -9. Okay, that's going to give me a 0. That's going to give me a 0. 1 times -3. Okay, this is looking promising here. All right, we got a 0, so yay. All right, we found one. It took a couple tries, but, we found it. All right, so -3 is 0. Got one of them. We're trying to get 3 of them. But now we can look at what we have left here after you divide that out. So, and I showed that in another video, but just take that polynomial, the quotient here, 3x squared plus 0x plus 1. We don't need the 0, so 3x squared plus 1. When does that equal 0? See, now that's quadratic. That I can solve. So I'm going to put the 1 on the other side. Divide by 3. Take the square root of both sides. I'm going to run out of room. Okay, so we have to do a little bit of work with this. So I'm going to come up here. We're going to say x equals plus or minus I square root of 1/3. Now you have to remember about radicals and how you can't have a radical, a square root in the denominator. So you have to rationalize it. We do that by multiplying by 3 in the numerator and denominator. That's going to give us plus or minus I square root 3 over 9. But I can take the square root of 9, so you could write it that way. How does the book write it? They put it this way. That's fine, either way. And so we have 2 zeros here. We have the positive and the negative. You can write them out. And then we have to remember the other 0 that we found. It was -3. So -3 was a 0. And then we have negative I square root 3 over 3. You can write it that way, or you can put it in a plus bi form. I don't care. And then I square root 3 over 3. So we had two imaginary zeros and just the one rational zero. Okay, so we found them. Oh, I said I would show you this problem with factoring. So the original problem said f of x equals 3x cubed, x cubed, plus 9x squared plus x plus 1. I think that's what it said. Oh, no, it was supposed to be a 3. I hope I didn't have a 1. It's supposed to be a 3. Okay, well, you can factor this by grouping. So you can take out an x squared, a 3x squared, and you'd have x plus 3. And then this is a 1 times x plus 3. And the only reason I'm doing this is because maybe you were thinking at the beginning, hey, doesn't this factor? And I didn't want you to think you were wrong, because it does factor. So then by grouping, so then you have x plus 3 times 3x squared plus 1. And if you'd gone this route, you could still get the zeros, right? So you say x plus 3 equals 0. That gets you the x equals negative 3. And then the other one, that's back to what we did. We already did this, but you'd have to solve it, and you'd get x equals plus or minus I square root 3 over 3. Those would be the same steps as what we did before. But that's what it would look like if you went with the factoring, because it does factor. Okay.